Welcome to this lesson on comparing rates. Today we're going to talk about how to compare rates that are written in different forms. So when we see them written as ratios or in an equation, in a table, or on a graph. So we're going to work on converting between each of those and then comparing them. Because again, you know that when we have to compare apples to apples. But we don't always want to have to take something and graph it. So we're going to look at how to most easily compare. So first we have to look at kind of how we can use each of these things. So here I have the ratio of blue paint to red paint is 1 to 2. So what I can do, and yes, this is written here, but we're going to go through it just to make sure we remember. I know that as a rate, so since it's 1 to 2, blue to red, as a rate, this will be 1 blue per 2 red. Then I know that if I'm looking for red, that red has to go on top for my rate and blue has to go on bottom. So it would be 2 over 1, and I would multiply that by my blue to give me my red. So here I can say that R is going to represent red, and B is going to represent blue. So I can make this even cleaner and say that R is equal to 2, because 2 over 1 is equal to 2, times blue. So we're kind of taking it a step further now. So what this tells me is that if I know my blue, I can find my red. So if my blue is 1, I multiply 2 by 1, and I know my red should be 2. I also then know that if my blue is 2, that I multiply that by 2, and that my red should be 4. I also know that if my blue is 3, I multiply 2 by 3, and my red should be 6. I also know that if my blue is 4, I multiply that by 2, and my red should be 8. Right, so I can use my equation to create a table. So if I had another table, I could use it to compare using the tables. And I could use that equation to fill in my missing values. So we're also going to now look at using those values in the equation again, just because we can always use that extra practice. So here I know that Miss Sipple, who is the librarian, enjoys reading. And she reads 3/4 of a book in 1 day. So my rate is 3/4 of a book per 1 day. So I also know that the way this is written, that it is a unit rate, because it is comparing 3/4 of a book to 1 unit. In this case, the unit is a day. So then I also know, so I want to know the number of books, because the number of days is easier to manipulate because it's a whole number. So if I want to know the number of books, I know that it has to be on top and days has to be on bottom. So in this case, I'm going to take it and I'm going to say, okay, then my number of books is equal to 3/4 over 1 times my number of days. I can clean this up and say that B is equal to 3/4, because 3/4 over 1 is 3/4 times D. Okay, and again, I can input my numbers, and I know that when I have 1 day, that she will read 3/4 of a book. Okay, so B is equal to 3/4 times 1. So B is equal to 3/4. Here, B is equal to 3/4 times, well, if it's 2 days, I know when I multiply straight across. So B is equal to 6 over 4. Okay, because remember, this is 3/4 times 2 over 1, which then needs to be turned into a mixed number because it's improper. So 4 goes into 6 once, with 2 left over out of 4, and we simplify that to 1 1/2. So in 2 days, Miss Sipple will read 1 1/2 books. And then I can keep going and plug in, and I know that in 3 days she will read fourths books, which is 2 and 1/4 of a book. And in 4 days, she will read 3 books. Okay, so I can also look at it this way with the 3/4. So if we say 3/4 book per day, that also tells me that it's 3 books per 4 days, which is also what we got right here. So you have to remember that when you have that 3/4 in the front, you can also turn it into, even though it's 1 day, you can also turn it into 3 books per 4 days and make sure that you're on the right track. All right, so now this is where we're going to start to use those pieces. So we have Brian and Shanice, and they're both training for a bike race, and they want to compare who rides the bike faster. Brian's app keeps track of it as a table, so this would be Brian. And Shanice's keeps track of it as a graph, so this is Shanice's. So we want to know, at what rate does each biker travel? Okay, well, in order to find the rate that they travel at, we have to look at the information the graph gives us. Now, in this case, we have 0 to 0. Well, that's not going to help us out at all. And we talk about rate, when we talk about rate, when we travel, we talk about speed. So with speed, it's always distance over time. So in this case, I'm going to look at my next column, so Brian. So Brian travels at 75 miles in 3 hours. So that's Brian. Cheyenne, then, I would have to look at my graph and say, okay, well, I know that she's 0, 0 as well, but that doesn't help. But I also see that if I go over to 1 hour on the graph and I go up, I can follow that over and see that it's halfway between 10 and 20, which is 15. So she travels 15 miles, but that's only in 1 hour. So there's a couple ways that I can compare this. So now this is Shanice's rate, and it's her unit rate. What I can do is make these both unit rates, or I can use the graph. But first, we want to explain how we arrived at our answer. So I'm going to look at it and explain. So we compared Brian's miles to hours and got 75 thirds miles per hour. We then read the graph and found that in 1 hour, and actually let's explain a little deeper. We read the graph by following hours over to 1, then following 1 up to the graph. From the graph, we followed over, make this a little smaller, to the number of miles and found it to connect with 15, giving us a rate of 15 miles per hour. And we can actually say 15 over 1 miles per hour. So remember, it just asked us for the rate. It didn't ask us for the unit rate or anything like that. So we looked at it. We can find the rate by following up the graph. So we look at the graph and say, okay, in 1 hour, I have to find where that is on my actual line on my graph. And then I have to find that point and follow it over to connect, see what number of miles connects to it. For my table, I just simply put my number of miles over my number of hours. Okay, so I can compare these, I just have to make sure I'm comparing the correct and the same information. So looking at this, if I want to know who rides their bike faster, I would have to do a couple of things, or I could do a couple of things. One, I could find the unit rate. Okay, so if I find the unit rate, if I find the unit rates for both, I know that I would have to say that it's 75 over 3, and I want to get that down to just in 1 hour. So I divide both by 3, and I get 15 miles in 1 hour. And I already know that Shanice's is in unit rate form because it's already 15 to 1. So I compared by finding the rates from both the table and the graph, and then I compared their unit rates. So that's one way that I can do this. I can also look at this and say, okay, well in 3 hours, Brian goes 75 miles. So I can look at the graph and say, all right, well in 3 hours, no, I'm sorry, 75 divided by 3 is definitely 25. Sorry, I was thinking about Shanice, so we have 25 miles per hour. Now in 3 hours, Shanice, if I follow that over, only goes 45 miles per hour. So then I can look and say, okay, well, using the graph, in 3 hours, Brian goes 75 miles per 3 hours, and Shanice goes 45 miles in 3 hours. And I know that Brian is riding faster. So now Shanice wants to win the bike race, so she needs to go faster. So her graph needs to show a faster pace. So again, we're still going to go with the same number of hours because time doesn't change. It is what it is. And then number of miles, and let's count by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. All right, so before she was going 15 miles in 1 hour, so it would have been right here. So 15 miles in 1 hour. She wants to go faster than that, so we can actually plot a couple of hers and see that her line went something like this. But she wants to go faster. So she wants to go faster, but she also wants to go faster than Brian. So we have to look at what Brian did. And we know that Brian, if we broke it down, he went 25 miles in 1 hour. And we found that by finding his unit rate, by taking his rate and dividing it. So then now we can use his unit rate and say, okay, well, he would be, so let's actually take Brian, and let's make him red. So Brian would be at, so 25 would be right about here. So then in 3 hours, we know he was at 75. So then his line went like this. So if he's riding faster than Shanice, we know that we want her line to be even steeper than that. So by putting both of them on there, we can look and see comparatively. So if you look at a graph and you see, ooh, this line is steeper than that line, and we're talking about speed, the steeper the line, the faster they go. Or the steeper the line, if you're talking about money, the steeper the line, the more expensive it is. So you have to kind of look at what you're comparing, and you can use the slope of the line to help you. What you can also look at is The slope of the line also will tell you the unit rate, because here, wherever 1 is, you can find what it connects with, and we found that it connected with 25 for Brian. So his unit rate was 25 miles per hour, where Shanice's was 15 miles per hour, and you know that that is actually slower than Brian. So we want it to be faster. So really all we have to do, she doesn't have to be much faster, but let's make it something nice and simple. So if he goes 25 miles in an hour and she wants to win, she's going to want to go 30 miles an hour at least. Because then in 3 hours, so in 2 hours, she'll have gone 60 miles. And in 3 hours, she'll have gone 90 miles. So if she goes 30 miles in 1 hour, she will beat Brian. And that should give us, based on what we learned, that should give us a steeper line. So let's see if that works. So 0, 0. Okay, so now no matter how long they ride, Shanice should beat Brian. Now there may be a point where he catches up to her, but for the most part, she should always be beating Brian. Okay, and now, like I said, you can use the slope of the line to also compare rates. All right, so now we have one where we have the equation and we have a coordinate plane. So here we want to look at rates. Well, at what rate does each girl stack her cups during the practice sessions? Well, we know that a rate in an equation is that first number listed. And you have to remember what you want to find is on top. So in this case, since it's 4, we know it's 4 cups per 1 second. And that's for Kate, because we know C is cups and T is seconds. Okay, and again, we know that the number, so we know that 4 is equal to 4 over 1, and what we're trying to find, in this case we were trying to find C, which was cups, goes on top, so that's cups. So, start with Kate. Kate stacks at a rate of 4 cups per second. And now we need to look at Miss Claire. Now we're going to do the same thing for Claire, and it's nicer to compare it to 1 because it gives us a unit rate right off the bat. So we look at the time, we look at 1, and we follow it up until it hits our graph, and that point is right here. And we follow it over and find that when she's stacking for 1 second, she stacks 5 cups. Okay, so when she's stacking for 1 second, she stacks 5 cups. Well, we want that to look the same as Kate's, so we're going to flip it. So we know that she stacks 5 cups per 1 second. Okay, and now we can type that. Five cups per second. Okay, so now Kate notices that she's not stacking fast enough. What would Kate's equation look like if she wanted to stack cups faster than Claire? Well, since Claire stacks 5 cups per second, and we're saying that, okay, well, her 5, we're comparing it to Kate's 4, we know logically that Kate's rate of 4 would have to be higher than 5. So her equation would have to look like this. Well, we shouldn't say like, it would have to look something like this. Now, she could use any number as long as it's bigger than 4, or 5. Sorry, it has to be bigger than 5. So hers could be cups is equal to 6 times T, Or you could even say cups is equal to 7 or 9 or 10 or 12. Okay? It would have to be anything. That rate, that number that we're multiplying by, would have to be bigger than 5. And we know that because that is Claire's rate. And if we took Claire's rate and turned it into an equation, again, cups would be equal to 5 times T. Okay, because we know that C is cups and T is seconds. All right, so here we have a problem that I gave you, and you have 3 different motorcycle companies or 3 different types of motorcycles, and he's trying to figure out which one is the most gas efficient. So you have to figure out who has the best mileage. Now, for efficiency with gas, you want the least amount of gas, or the most amount of gas per miles. I apologize. So if you get 10 gallons per mile, that's better than if you get 2 gallons per mile. So I want you to keep that in mind when you are comparing using your graph table and equation. So I want you to figure out how you want to compare, whether you want to put everything onto a graph or put everything into a table or put everything into equations and use. It's up to you, but you need to compare each of these and tell which motorcycle is more efficient. As always, if you have any questions, be sure to write them down or email me so we can go over them in class.